Welcome back, and we are continuing with numerical summaries. The last video we talked about measures of center or measures of central tendency. The mean, median, mode are what you were exposed to. And in this video, we're focusing on spread. So you're going to learn how do you summarize a data set, in particular how scattered it is based on concepts such as the range, the IQR, which is the interquartile range, the variance, and standard deviation. So let me go through them first. The range is simply just the largest value minus the smallest, so the max minus min. It's how spread out literally your data are from the smallest to the largest value. Now, it's an easy one to get to compute, but it's really bad if you have outliers, because obviously your outliers are going to be either really small or really large. So they will be your max and or min. So the range is not robust at all. But then someone came along with a more robust measure, which is the IQR. That's interquartile range, which is the distance between your first and third quartiles. And those are going to be more robust measures because the third quartile is the value for which 75% of the data is at or below, which means 25% above. And so by taking that Q3 or the third quartile, you're ignoring the top 25%. So the largest values, which is one place your outliers might be. And Q1 is the value that has 25% of the data at or below, which again, that would be your smallest outliers if you have any. And so finding the distance between Q1 and Q3 is most likely going to be ignoring any outliers that you have. So let's think about what the IQR means. If you've got the value that has 75% below, and you have the value that is 25% below, and you find the distance between 75% minus 25% gives you 50%. But it gives you a very specific 50%. The IQR is the distance of the middle 50% of your data set. So it's a very specific distance and with respect to your distribution. So a neat one to use. Now the variance, which is denoted with a little s squared, the 2 is important, is given by this formula in the center there. It is the sum of the squared distance that your observations, your x's are, from the average value, which is x bar. So x minus x bar is the distance that your data are from the center value. You square it because sometimes the distance is positive, sometimes it's negative. It depends on whether your data value is above or below the mean. And when you square, you never have a negative number. And then when you add up those distances, you divide by n minus 1, not n. So it's almost an average. It's a little different, and there is a theoretical justification for it, which is beyond the scope of this class, but it is justified. It's a better estimate when you divide by n minus 1. So that is a formula that you're going to see in most textbooks. Some textbooks, not often, will have the one that I've highlighted or boxed out in rainbow colors here. And I prefer that one personally for computation purposes. I think that it's easier, students are less likely to make mistakes with it, and you'll see how to use each of these formulas. The last concept is the standard deviation, and that is simply just the square root of the variance, because the variance could be a large number. And when you square root a number, it becomes smaller, or almost always becomes smaller. And standard deviation is going to be s. So just like variance was s squared, when you square root a square, you just get the unsquared version. So what do these concepts mean? Well, the s squared, or sample variance, is approximately the average squared distance from the mean. When you square root that, you essentially have the average distance from the mean, which is a bit more easier to grasp. So in practice, standard deviation is a common concept to compute. How do you do these? Well, let's go ahead and look at problem 4 here. And problem 4 asks, what is the variance of SAT math scores among freshmen at Georgia Southern University? you're given 5 observations here, and we want to figure out what's the variance. So the first thing that you need is the mean. So you should go ahead and you should calculate that. So we've got n equals 5 observations. And when you calculate 490 plus 580 plus 450 plus 570 plus 650 divided by 5, you should get 548. Happens to come out to a nice integer value. It's not required, but it does in this case. And we're going to use that in order to confirm these variances or variance and standard deviation that you see in the center there. And so those are the answers. How to get them? Well, let's do the common textbook formula first. And this one I think is really good to show in kind of a tabular format. And so I've listed out a table here where X are just my data values. It's not necessary to put them in order. I didn't. I just wrote them in the order that they were given in the list. And according to the formula, let me just show that once more, I need X minus X bar. So that's the first thing I get is I do 490 minus the mean or X bar of 548. So 490 minus 548 gives me negative 58. 580 minus 548 gives me positive 32. 450 minus 548 gave me negative 98, and so forth. So that's how I got that middle column there. But then the formula says, well, when you have those distances, I want to square them to get rid of the negative values. So when you square, remember, if you don't use your parentheses in your calculator, the negative sign may not disappear. So just be careful with that. When you square negative 58, you should get 3,364. 32 squared is 1,024. Negative 98 squared is 9,604, and so on. So now we have the squared distances. Let me check our formula again. And so it says in that numerator, it says after you have the parenthesis part, the squared distances, you've got that Greek symbol, which means sum or add together. And then after we add together, we're going to divide by n minus 1. So we add that third column, and that gives us 24,880. And we divide that by n minus 1. Remember, there's 5 observations, so that's 5 minus 1 is 4. And 24,880 divided by 4 gives us 6,220, which is the center value that I have on the left side there. That's the sample variance. Standard deviation, remember, is the square root of the variance. So if you square root that value, you get a smaller number, which is 78.87 about. So that's using the first formula, which again is common in textbooks. But let's see, how do you apply, or how does the process compare to the formula that I've got here boxed out in rainbow colors? So let's see, the bottom doesn't change, it's n minus 1. It's the top that looks really different. I'm going to need 2 components that I've got in parentheses there. I need the sum of the squared data values. That's the first parentheses on the top left. And the right parentheses is just the square of the mean. So the sum of the squared values. This is not the same as the square of the sum. So it is important you square first and then add up. So let's take a look at how to do that. Over here, I want the sum of squared values. And so I want 490 squared plus 580 squared plus 450 squared plus 570 squared plus 650 squared. And when you add those squared values together, you get a really big number. You get 1,526,400. So that is the top left part of that second alternative formula, which I've got in the middle here. Minus n is 5 times x bar squared, which is 548 squared. And when you multiply first, then subtract, and get your numerator, and then divide by 4, you should get the exact same answer of variance, which is 6,220. Again, this is my preferred approach to computing variance. It is, in my experience, it tends to be easier, faster, less likely for mistakes to happen. You don't have to do it that way, but I definitely think it's better, especially when your mean is not a beautiful integer value or your data values aren't attractive numbers like we have in this data set. So, but both variance formulas, let me show them once more. Both variance formulas are equivalent. So if you do each right, you should get the exact same value. Now, at this point, let's look at number 5 here. It says radon is a naturally occurring gas and is the second leading cause of lung cancer in the United States. 4 radon readings from homes in the local county are 7.1, 11.6, 8.1, and 13.4 picocuries. Compute the mean and standard deviation. And so I want to give you about 10 minutes to see how far you can make it on your own. Again, you need the mean first because the variance uses the mean in its formula, and you get the standard deviation from the variance. So pause the video, try to tackle for this, and we will return in a minute. All right, so let's see how you did. Again, hopefully you tried it on your own, because part of what's important for this type of class is to practice and to practice recall. And so at this point, I know it may be new for many of you, but try to just look at the formula and not so much example problems, even though they're good examples. And it will really benefit you to practice your recall when trying to do these things on your own. So let's take a look at how you did. First thing you should have done is compute the sample mean. When you add up these 4 numbers and divide by 4, you should get 10.05. It comes out to that perfectly. Don't round, don't truncate, use 10.05 exactly. So don't use 10 or 10.1. 2 decimals is not computationally hard for your calculator. And then you'd want to compute the variance. And you can see here that I used what I've said is my preferred formula, but the standard textbook one is fine. You might have some different values in the computation, but in the end, you should be able to get the same answer. So going with the second approach, I needed to get the sum of the squared data values. So I squared each of the values, 7.1 squared, 11.6 squared, 8.1 squared, and 13.4 squared, added those up, minus n, which is 4, times 10.05 squared, x bar squared value. And when I divide that numerator by 3, which is n minus 1, I got 8.71, but the problem asks for the standard deviation. And so that was the variance. And when I square root it, I get S is 2.95, and that is the standard deviation. So that is telling me that the average distance from the mean, so the data values on average are about 2.95 units or picocuries from the average value of 10.05. That's what the standard deviation means. Now, you've seen an example of range back in problem 1. You've seen variance and standard deviation. You haven't made use of IQR, so I do want to use some of these examples to demonstrate how I recommend getting the interquartile range. There's a few different ways, but I'll show the one that I think is typically the easiest or the fastest approach. And I'll use data set 3 here to do that. And so with this third one, the first thing that you're going to want to do, and you do this with any of them, but I'm just doing it with this example, is you're going to want to find the median of the whole data set, which we already did, and we found that to be 15. Or, sorry, not 15, we found it to be 22.5. So I'm going to make a cut in the data set at where that value would be. Remember, that is the 50th percentile. The median is in the middle, and so that's the 50th percentile. So what I'm going to do now is I'm going to find the median of the left half which will give me the 25th percentile. So half of a half is 25%. And half of the top quartile will give me the 75th percentile. So essentially I want to find the median of the left side, median of the right side. And that's what I'm going to do. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values on the left, 10 values on the right. This is an even number, so the median is going to be the average of the middle two. And so that's going to be the average of the fifth and sixth. 1, 2, 3, 4, 5. The fifth and sixth. And on the right side, 1, 2, 3, 4, 5. You've got these as the middle two. And so that means that Q1 is going to be the average of 15 and 15, which is 15. And Q3 is going to be the average of 40 and 45. And that's going to be 42.5. And so according to the formula for IQR, here you want to find the difference or the distance between these. And so that's 42.5 minus 15, which is 27.5. And that is the interquartile range for this third data set here. Let's look at another example. We could take a look at number 4 here. And here you had just 5 observations, so it's another small data set. And the median we didn't find, but if you order this, you've got 450, 490, 570, 580, and 650. And so now it's in order. The median is the middle value. This is an odd number data set, so it's this one here. So I'm going to cut through that to split the data in half. I'm not including that value on either half. And now I've got 2 values to the left, 2 values to the right. So Q1 is going to be the average or middle value here, which is going to be 470. And Q3 will be the average on this side, which is going to be 615. And that means that your IQR is what? Well, when you find the difference, you've got 145. Again, that was 615 minus 470. So let me have you practice that idea on this 5th data set, this 5th example. Find the IQR. You should pause the video here, and then when you're ready, start it up and see if you got the right answer. All right, so let's check this out. You could see that magically the solution has appeared on the bottom right here. And I've ordered the data values first. So again, that's really important. Put them in order. And I can see that the median with this even data set will be between 8.1 and 11.6. And so when I cut the data set in half here, I want the median of both halves. The median of the left side will be 7.6. The median of the right side will be 12.5. And the distance between them is 4.9. And that should be the interquartile range that you got. So hopefully you're able to get it and you've got a good amount of practice with these concepts. That is it for measures of center and spread. And what's coming up next is how to interpret graphs.